Looks like it's recording then, probably. Yeah.
Yep. Yeah, you're good, man. Thank you.
Oh, awesome. The presentation. So yeah.
Please continue.
No problem. And then the next thing up, and it's this whole size thing starts to kind of break down here, is high energy astrophysics. High energy is specifically looking at objects like black holes. All of these fancy words you kind of see on the board, like quasar, active galactic nuclei, are kind of different names for black holes or black hole-like objects. We also deal with stuff like white dwarfs and neutron stars, which are just stars that have kind of aged to the point that they no longer act like stars. They do very, very different things. To give a quick rundown for anyone who doesn't know what a black hole is, they are just these really heavy stars that are so heavy that they collapse to the point where light can no longer escape their gravity. And that is when something becomes a black hole. So when light can't leave from the surface of the object, it no longer radiates anything and actually becomes really effective at sucking things in, which is called accretion. And when it does that, it'll create either kind of these shocks or in some cases jets in the top and bottom. And those jets are what we kind of are able to study from these black holes. In the case of active galactic nuclei, they are similar to our galaxy. There are occasionally large groups of black holes or black holes themselves called supermassive black holes that exist at the center of galaxies. And because of their positioning in galaxies, they tend to accrete a lot of mass, to take on a lot of mass. And in doing so, they create a lot of light outwards. Yes, there is some theory around, there's a question in the chat, there's some theory around time travel in black holes. One thing that I do know for a fact, and I have heard that discussion come up in the field kind of seriously. What I do know for a fact is that because of the high levels of gravity, you can actually affect how time goes. So if you've ever seen the movie Interstellar, when they go on that planet and then jump through a bunch of time, what's happening there is they're really close to a black hole. And because they're really close to a black hole, their time kind of relatively slows down. And the people on Earth are moving faster, they age faster. And that's why in that movie, you ended up with him being much younger than anyone else. Next is galaxies. That's kind of the next size up. Again, it gets a little shady from here, but they are the things that host the stars and planets and black holes that we're interested in. When you look at the night sky, barring a few objects, you are looking at all things that are in our own galaxy, the Milky Way. There's the Andromeda Galaxy and a few other somewhat visible galaxies and clusters that aren't considered a part of our galaxy that are naked eye visible, but every star, every planet, every comet, asteroid, whatever you see is in our own galaxy. Luckily, we have these fancy tools called telescopes that let us see things our eyes can't, and that allows us to observe galaxies which would normally be invisible. They're important to us because they can teach us a whole lot about stellar evolution. So it kind of, when we are observing these, we're also looking kind of back up the chain a little bit at black holes and stars, because when you look at a galaxy like the one in this image, those kind of bright bands are the places that star formation is occurring. So looking at these galaxies will teach us what's happening at the places where stars are forming. Cosmology then is kind of the study of everything in a way. It's asking questions about the universe as a whole, not just the objects in it, specifically about the formation of the universe and how that formation has like heavily impacted the universe we're living in today, obviously. It also is concerned with kind of the large scale structure or behavior of the universe. What you're actually looking at in the background is an artist rendition of what we believe to kind of be these filaments of mass distribution in the universe. And that's a little bit confusing, but what it means is we kind of notice that when we look out around us, that objects tend to be in kind of filaments like that. So the bright areas are where there's a lot of stars or gas or dust. The kind of corners of those where they meet are areas with large galaxies or even clusters of galaxies. And then the rest, we're not really sure why, but seems to be relatively empty as compared to everything. Another thing we kind of are interested in is how the universe changes over time when we're looking at cosmology. You might have heard of dark energy. That's a lot of what cosmology deals with, because dark energy is the source of energy that we observe to be creating this unending and actually speeding up expansion in our universe. You'll see the word dark appear a few times when I talk about astronomy. If we use the word dark, it really could just be substituted for we don't know, because when we call something dark matter or dark energy, we're just acknowledging that we think there's energy or matter there that we just can't observe, we can't see, so we don't really know it's there. The last branches of astronomy I want to talk about that are kind of a touch different and do some interesting things and are kind of the field that I am personally looking to pursue are computation and instrumentation. They sound similar, but they really couldn't be that much different, that much more different. Computation typically deals with data modeling, simulation, or processing of huge amounts of data. Computational astronomy is often juxtaposed to observational because observational astronomers use observation, and computational do sometimes, but they mostly stick to just what their computers tell them. But computational astronomy isn't just one thing. So it kind of varies from either simulating the very small scale interactions that happen inside of stars or planets, all the way up to simulating how the stars in a galaxy or galaxies in a galaxy cluster interact with each other. The next thing is instrumentation. That is really, really a broad category and not super astronomy. It kind of borders on engineering a little bit more. And that's specifically anything from like being on the mountain. This photo you're actually looking at right now is a photograph of Tip Peak, a mountain in Arizona. I didn't believe it was a photograph when I first saw it, but I did some digging and found that apparently it was taken on film. So it really is. But whether you're up on the telescope kind of doing maintenance, cleaning mirrors, or the one who helps design the instrument they're actually putting on it, there's kind of also a lot of fields in here that aren't necessarily directly doing astrophysics, but still aiding in astronomical observation or working in astronomy in some way. And I think these are kind of two of the more important fields of astronomy that get overlooked sometimes, because of the amount of support they provide to the rest of the astronomical community. They are immensely important to whether you're in instrumentation and you're fixing the telescope or you're the one who knows how to operate it. If they don't have you, they can't take observations, or you're in computation. You're the guy doing kind of the back-end work that these astronomers need to be able to do their research. Where did all of that go? Oh no. Okay, well, I had a slide called Qualities of an Astronomer with a lot of stuff on it that has seemingly gone away. So I'll just quickly talk through that because I know what I had to say. The first thing is that you probably do want strong math, science, technology skills. I'm guessing because you're here, you're probably already working on that. One thing I will say about astronomy that caught me off guard was the amount of computer science that is involved. So if you have a chance to kind of start working in some coding, it would be good if you want to pursue a future in astronomy. I think there's also some more qualities of astronomers that aren't talked about. You need to be ready to kind of do counterintuitive things to get the results you want. Because as I alluded to earlier, these objects we're interested in are so far away, we occasionally have to get creative with how we observe them. So like one instance I think of this kind of ingenuity in astronomy happened a couple of years ago when we got that first image of a black hole. It is likely the largest, it's likely the highest resolution, angular resolution. It didn't look very good, but that object we were observing was very small. Observation that humans will ever make. We may make bigger observations, but that's kind of far in the future. And the reason why, because we use the fact that we can take observations on more than one telescope and combine them to make the accuracy of our images better. And it actually plays into kind of a quirk of optics and physics. But basically, the end of the day, the kind of angular accuracy of your telescope is limited by the size of the mirror. And so by combining multiple telescopes on Earth, we effectively made a telescope the size of the Earth. And so that's why I like to say that observation is the highest angular resolution we'll ever get, because it's unlikely, unless we start launching large amounts of space telescopes, vast distances away from Earth, that in the near future we'll ever actually see anything much smaller than this object was. The last thing is, and I talked about it in my personal slide, is you kind of need to be an accepting person. Astronomy is a more diverse field than a few of the other natural sciences. And not only is it diverse in kind of the ways we typically think of diversity, but I also found it to be a very intellectually diverse field. Anywhere from people who enjoy it because they like to write about astronomy to nerds like me who enjoy the astronomy but like the computer science, all the way to the kind of super nerds, I guess, that do the hardcore, like 500 observation data analysis, kind of really intensive stuff. So you need to be open to kind of addressing, you need to be open to experiencing a lot of different people of a lot of different kind of philosophies and mindsets in the field. So the last thing I'll leave you with, kind of, since I think I'm getting close to time here, but I don't see a clock right in front of me, is some resources if you want to learn more about astronomy. There's plenty of stuff out there if you just Google astronomy, so I trust you to do that. But these are kind of a few that I think kind of get left behind. Astrobytes is a really awesome website. It talks a lot about, it kind of tries to put papers into context that other people can understand if you're not someone who has studied astronomy for a long time. But they also have a lot of good kind of pieces about getting involved in the field of astronomy, what it's like to be in that field once you get there, some of the like kind of things to look for while you're trying to get a degree in that field. It has a lot of really useful information. The next would be the NASA ADS website. If you want to look at astronomy papers, this to me is the best way to do it. It's fairly easy to search. It takes a little bit of time getting used to, but it's not too hard from there. And it's kind of a really good tool for doing research. Oh, thank you for the time check also.
Could you put the link in that chat? Could you put the link in the chat?
Yeah, I can do all of that in a second here. Unless you have someone else doing it, yeah. Next would be NEA, CSC, Swift. So these you might want to contact me if you want to know more information about. They're names of different observation sets that are completely accessible to the public. So the one I'm really familiar with is NEA. That stands for the NASA Exoplanet Archive. And it's completely free to access for anyone. And you can pull all of our confirmed observations of exoplanets from it and do whatever you want with the data. It has almost anything you could imagine wanting to think about, including stuff like the orbital radius of the planets or the luminosity of its host star. A lot of kind of other more technical things that I won't get into. But if you're interested in kind of looking at data, there are ways to get that data completely free and publicly accessible. The last thing, and it kind of is a personal plug, would be the University of Michigan SAS. We're open to the public. Both our open houses and our general meetings are. So for the time being, we're doing everything over Zoom. So if you want to come to our meetings, we actually have one tomorrow night. If you're interested at 8 p.m., it'll be on our website, which I'll send the link to all of these in the chat in a second here. Feel free to come. We also do open houses on Friday nights, which are just kind of a chance for us to show off, in the past, our planetarium and telescope, but because of COVID, the great skills in Stellaris that some of our members have. So we are also a resource. As I mentioned at the top, I'm Dante. On the website, it has contact information, I believe. If not, I can get that to you if you're interested in talking to me more. I am kind of wrapping up here. So if anyone has any other questions, feel free to ask. I am going to put those links in the chat here.
All right, let's go ahead and give Dante a digital round of applause or a digital thumbs up, or show him some love in the chat for that very informative presentation. Thank you again, Dante.
No problem. Let me get those links for you.
And then, are there any questions about astronomy? Did you first, did you know what a quasar was before you watched the presentation? Did you know what cosmology was before you watched the presentation? Any questions that you may have?
So do you believe in a Big Bang theory?
Yeah. I think there's still a lot of work to be done to kind of figure out what exactly that means, but I do think that currently all evidence points to the fact that we probably started from a very small point.
Yeah, but I thought like matter couldn't be, or energy couldn't be created.
That's
destroyed.
Yeah, so that's where we kind of get, that's the work that I said needs to be done. We don't think that matter was created in the Big Bang. We think the matter was already there. We just don't really very well what that means. One of the issues actually in studying this that I can point out is something called the cosmic microwave background. So when you look, light takes time to travel. It doesn't move at an infinite speed. So when I look further and further out, I'm actually kind of looking backwards in time. And if I look far enough out, I see this kind of just spread out smear of very, very low energy light. And that's mostly because of high energy light, but very, very dim light that is coming from very, very far away, which also probably means very, very old. We think that at one point in time, the universe was kind of this a big blur of like protons and neutrons, and that is what we're seeing when we look far. So there's kind of this wall that we hit when we try to look too far back in time, and that wall is what is stopping us from knowing where all this matter came from.
Yeah.
Right.
Okay. Yeah, so there's just a lot of stuff that we don't know yet.
Yeah, that's one of the great things about astronomy is it is one of the fields of science that there is still new things going on. Like, for example, I study exoplanets. That's what I know a lot about. We have detected somewhere around 4,000 exoplanets confirmed, but that's all been since the 90s. So like even these kind of big fields that we think are important to astronomy are things that are just now starting to develop, and a lot of it has to do with the technology.
Gotcha.
Whitney, did you have a question? No.
No. Well, if you look in the chat, if you.
Yeah, black holes aren't baked actually. I did research on them for a semester or so. They're fairly interesting objects. I kind of lost interest in that just because the work I was doing wasn't super important, but there was, yeah, it didn't feel great, and I wanted to do exoplanet stuff, so I moved on to something else. But they are, the field of studying black holes is good. It's just the person I was working with wasn't doing super compelling research. Remnants of old stars in those cases. So when a star gets old enough, the core starts to collapse. When it collapses, it gets hotter, and that means that it can start burning more stuff through nuclear reactions. Eventually, it gets to a point where it can no longer burn the things with nuclear reactions, so they just collapse. When they collapse, they can fall to radii less than something called their Schwarzschild radii, which is just a fancy word for the place where light can no longer move. And once they do that, light gets trapped inside of them, and we don't really know what happens next. All we know is that they attract a lot of stuff, and they're pretty dangerous to get close to. Anyone else have questions?
Thank you. Any other questions before Dante leaves?
Guys, I didn't.
All right.
One more important site. Our website. yeah, so all those are going to be good resources. I would, without guidance, stick to Astrobytes and SAS. But if you want to look at ADS a little bit, it can have some interesting stuff. It is refereed published papers, so it's kind of heady and intellectual, and without having kind of studied astronomy, some of it might go over your heads. But if you want to learn by reading stuff that's too complicated, that's a great option for you.
No, I gotta go on Fate. So
Yeah, we're about to go.
okay.
Yeah, so thank you again, Dante. Thank you so much, man. Really, really dope. Hopefully we can see you again next week or someone else from your team. Everyone, thank y'all. Please thank him in the chat. Show him some love. He does not have to be doing this. It's 3 o'clock. But he came through and messed with us. Thank you.
Thank you.
I enjoy it. As you can tell, probably I enjoy talking to people. So, any chance I get, I probably will be back next week if you guys want a presentation, but we can work that out outside of the call or in the call after one.
Perfect. All right, family. Text me your individual messages so I can send you the gift cards. And then Dante, you have a blessed day, okay, man?
Awesome. Thank you.
All right. All right, y'all. Take it easy.
All right, Nello.
Thank y'all for coming. Make sure y'all text me.
Did you want me to stay?
And Dante,
Oh, yeah. Okay.
go ahead. Yeah. Can I have your contact information?
Yeah, I'll send it in the chat quickly. I figured Kevin would have sent it to you by now, but that's my email, and then I'm sending my non-school email because I'm graduating in 2 weeks. So if we're talking after I graduate, then feel free to contact me at that one.
Yeah, man. Cool. How
I'm
you
happy
feel?
to do this. Yeah, I'm happy to do this for as much as you guys want. I enjoy being in front of people and talking. So
Yeah, I would love us to like just maybe talk about like, you know, like maybe like specific astronomy related topics that are happening. And we can just dive deep into them, just kind of like call it like a astronomy news day, like what's in the news of astronomy, or it could just be like, you know, what's the Andromedan galaxy? You know, why is this important? You know, yeah, I was thinking something like that. Since you gave an overview, now the next ones could probably be a little bit more centered on like a specific astronomy topic or cosmology topic.
yeah, so if you want, I was on the outreach board in previous years. It's just this year I got to VP, so I took that out. But I have a good amount of presentations kind of that are tools for this, so I can go through them and send you like what the topics of them are if you want to pick out one.
Yeah.
Yeah.
That sounds great.
I might have to look through the drives a little bit. I don't have them right on hand, so I could email you that maybe a little bit later this week. But
that's fine. And then what was I about to say? Oh man, I forgot it. What was I about to say? Oh yeah, could you share that recording with me whenever it's ready? Just email it to me.
Yep.
Thank you.
Great. Awesome.
All right, brother, man.
Yeah, I had a great time working with you. I'm excited to come back actually. So
dope. We're excited to have you back, man. That's the point. We gotta make sure you're having fun, man. What's the point of doing this if you're not having fun?
Exactly.
Absolutely. All right, brother, man. Well, I'm gonna holler at you later, okay?
Yeah, have a good one.
All right, I'll see you later, man. Bye-bye.
Bye.